If you want to build products confidently with AI, this video will show you how. In this demo, I am using Cursor and Opus to generate a complete application from a single structured prompt. Instead of relying on vague instructions, I reference architectural and state management rules directly from the Reflex repository. Here, the project scaffold is being generated. Effect keys. These represent side effects such as API calls and local storage interactions. Event keys. Events describe all state transitions in the system, from initialization to fetching issues and updating UI filters. Subscription keys. Subscriptions describe how derived data is read from the state, including filtered issues, selected items, and computed counts. At this stage, we are not implementing logic yet. We are defining the architectural contract. Later, handlers will be implemented based strictly on these keys. Here, it is important to clarify what events actually are. Events are simply a collection of independent functions that produce a deterministic mutation of the application state. Each event takes the current state and input data and returns the next state. They do not reach outside their scope, they do not depend on external modules, and they do not perform any side effects. This makes the state layer predictable, testable, and fully deterministic. At this point, the application is fully implemented. Let's run the tests and verify that everything passes. Now, we start the development server and launch the app. At first glance, we do not fully know how it behaves. So let's explore the functionality and see how the system works in practice. Now let's enable the Reflex DevTools. Instead of reading the source code, we will inspect the application through its state model. With DevTools, we can inspect the current application state in real time and watch how it changes after each event. We can observe events being dispatched, effects being triggered, and subscriptions recalculating derived data. The goal is to understand how the application works purely from its state transitions and data flow without opening a single file. Here, we can see that after the state was updated by an event, a reactive recalculation of subscriptions was triggered. Those updated subscriptions then caused specific components to re-render. We can also inspect the subscription graph, tracing the dependency path from the state to the derived data and finally to the components that were re-rendered. This makes the full data flow explicit and observable. We can also inspect all registered handlers in the system, grouped by type. This includes events, effects, and subscriptions. Additionally, we can sort them by frequency of execution. This helps identify which parts of the system are most active and provides insight into runtime behavior. We can also execute any event directly from the DevTools UI with arbitrary parameters. This allows us to simulate different scenarios without modifying the code. For example, we can mock API responses, test edge cases, or reproduce specific state transitions. It becomes a controlled environment for validating behavior and experimenting with the system. If an event has an FX badge, it indicates that the event triggered a side effect. We can then inspect which specific effect was initiated and examine the exact parameters it was called with. This provides full visibility into how state transitions lead to external interactions. Now let's ask Codex, using the Reflex MCP server, to inspect the current state and the event history and generate a performance summary. I wanted to describe what we have been doing in the application and what the current state looks like right now. This is especially useful when you are debugging a functional bug that only happens in a specific state. And it is just as useful when you are investigating performance issues in a specific user scenario, because it can summarize the busiest events, the triggered effects, and the subscription activity. Now, let's walk through the code, starting with the UI layer. As you can see, the components are intentionally simple and easy to understand. They receive input data exclusively through subscriptions, and they communicate changes exclusively by dispatching events. There's no business logic or heavy computation inside the components. This keeps them predictable, easy to reason about, and easier to optimize from a performance perspective. Next, we move to the application state. The important thing here is horizontal structure. Fields should be organized clearly at the top level with well-named self-documenting keys. Here, it is important to clarify what events actually are. Events are simply a collection of independent functions that produce a deterministic mutation of the application state. Each event takes the current state and input data and returns the next state. Subscriptions are built from two layers. First, there are root subscriptions that read specific fields directly from the state. Then, there are computed subscriptions that derive values from other subscriptions, forming a dependency graph. Subscription handlers are pure functions. They take inputs and return derived outputs with no side effects. That makes them easy to reason about and straightforward to cover with tests. You can see how easy it is to reach 100% test coverage for events and subscriptions because they contain no side effects. In tests, we simply take a handler by its ID, provide input state and parameters, and assert on the returned output. This gives fast, deterministic tests that validate the entire state and subscription layer. Try Reflex yourself at reflex.js.org